This tutorial is going to focus on mole ratio. So we are given two different chemical equations. They've already been balanced. We are asked that given these, we need to identify the mole ratio between the substances that we are asked for. Alright, so the first equation, we have sodium reacting with chlorine to yield sodium chloride. And it's already been balanced, so a coefficient of 2 out front of the sodium. Remember, when there's no coefficient, it's just a 1. Then we have a 2 out front of our sodium chloride. And the first mole ratio we're asked is between sodium and sodium chloride. I'm asked for sodium first, so I'm going to write that there are 2 mole of sodium for every 2 mole of sodium chloride. So I'm just looking at those coefficients out front, right? For the second one, we're asked what's the mole ratio between chlorine, the reactant chlorine, and the sodium chloride compound that is produced. All right, so there are 1 mole of chlorine reacting with sodium to yield or produce 2 mole of sodium chloride. So in this unit, these are going to become our conversion factors. They're going to allow us to go between our reactants and our product and vice versa. All right, number 2. We have potassium reacting with aluminum fluoride to yield potassium fluoride and aluminum. So we're asked what's the mole ratio between aluminum fluoride and potassium fluoride. Alright, so I'm going to look at my coefficients. There's 1 mole of aluminum fluoride for every 3 mole of potassium fluoride. And the last part of number 2, mole ratio of potassium and potassium fluoride. So there are 3 mole of potassium that reacts with aluminum fluoride for every 3 mole of potassium fluoride produced. So on the first part of number 1 and the second part of number 2, when you have a 2-to-2 relationship, that's the same thing as a 1-to-1. Or on the bottom, when you have a 3-to-3, that's the same as a 1-to-1. But you're not going to have to reduce unless you just absolutely want to. Alright, so practice some more of these on your own. Remember that the big ticket item with this whole unit of stoichiometry and finding the mole ratio is remembering how to balance a chemical equation. So making sure that we have the same number of atoms of each element on both sides of our equation. Alright, thank you for stopping by.